All right, here we're going to go into the next section and deal with what we call common logarithms. Just a forewarning, I have 15 minutes for this video, and some of my examples I'm going to have to go through rather quickly, so there may be a number of places where you need to pause to go back and look at what we did and watch the steps a little slower or just kind of absorb them. What a common logarithm is when we go in and say, hey, I'm just going to do log base 10. Okay, and so one of the other things that will happen is we don't write the base. So whenever I see log of something, such as I do in this number 1, that means I'm taking my common log, which is simply looking at the situation where I can now use my calculator. Okay, the logarithm button on your calculator right here is when we're talking about log base 10. Okay, so now if I need to find that log of 894.3, all I have to do is type it in. I get 2.95. Now, here's another quick situation here. If I go log, I'm not going to go base 10 again. I'm just going to leave it as log of, let's say, 1/2. So I'll type it in as log of 0.5. I'm going to get a negative number. Okay. What's going on here, and again, this comes from your exponents, because remember, logarithms and exponents are inverses of each other. Whenever I take the log of some number, and that number is greater than 1, I'm going to get a positive value. If I'm going to take a log of some number, but a is between 0 and 1, that's when I get negative values. And it comes from the idea, again, that what we're looking for when I take the log of that 894, that log of the 1/2, we're looking for an exponent. And if you think about when my exponents are greater than 1, I had exponential growth. Okay, when my exponents were negative, or when it was between 0 and 1, I'm sorry, they were decay. Excuse me. Now this anti-log thing, if you look at your button here for logarithms, okay, and then you look right above the logarithm button itself, you see 10 to the x. That's your inverse, log base 10. Okay, now when we go to exponential, we're going 10 to some power. Okay, so all this is really saying is, hey, I'm going to go 10 to the power of negative 0.06. But it's just your second function. Okay, and then your negative 0.06, enter. All right, so we're going to run into a situation where we have change of base formula now. Is going to be something that helps us out with some things. If we think back to some earlier problems, if I was doing log base 2 of 8, how we did that in the previous assignment was we'd let it equal x, rewrite in exponential form, get like bases, and then since my bases were the same, the expressions were equal, my exponents had to be equal. If I go on to do that to this log base 4 of 12, okay, and I rewrite it in exponential form, I'm not going to be able to get 4 and 12 in terms of a like integer base. Obviously I can get it in form of the same base, but I'm going to get it not in an integer value. So the change of base form is going to help us, and here's where it comes from. If you think back also, we had those properties of logarithms in the previous section. One of the things talked about equality. Okay, if I had the log of this, it was equal to the log of that. Okay, we wanted to get to that point because if that was true, then this and that must be the same. So now instead I have this equal to that. So if I take the log of this, that's going to be equal then to the log of that as well. But again, just think about it as I'm doing the same thing to both sides of my equation. Okay. Well, people always ask, how do I know that I'm going to use logarithms? Well, what we look for again is if my exponent is in the variable, or my exponent contains the variable, that's when I know I have to use logarithms. Okay, because now my next step here is going to be thinking of that power property where when I have an exponent on the inside, what I can do according to that property is bring it to the outside and front in terms of multiplication. I can change that to log 4 times x equal to log 12. Now, log of 4 and log of 12, they are a number. I cannot take that apart. It has to stay log 4, it has to stay log 12. Okay, so I can't take it apart. It's kind of like when I compare it to trig. You know, when you have sine of 30 degrees, I can't divide the 30 out of that. You have to keep those two together. So, early on, sometimes I suggest that you may want to put these in a group of parentheses so you remember that you can't tear those apart. Now, I could change them to decimals, but then I'd be rounding off and I'd create some error. But think about this. If I had 4 times x equaled 8, well, what we do is we divide both sides by 4. So it's the same idea. I have something times x, so to get rid of it, I'm going to divide that something away. But again, I need to do it on both sides. Now again, remember, each of these is its own piece. I can't take the 12 divided by 4 and say that it's log 3. Okay, it's log 12 divided by log 4. And so now we can get into our calculator stuff. Okay, and one of the things you have to be careful of, because these calculators now always throw these parentheses at you, and some of them even have bases on there. But with the parentheses, how I always want to get things down to before I start punching the calculator is the log of a numerator, log of the denominator. I don't want any extra stuff if possible. Okay, so what I'm going to do is I'm going to type in log of 12. Okay. And because that parenthesis, I'm just going to hit enter. And that gives me the value for log of 12, 1.8 or 1.08. Now, what I want to do is divide that, and this is one of the good features of the calculator. It brings that last answer with. I want to divide that by the log of 4. And there's my solution, 1.7925. Okay. All right, so that's how I'd solve that. But now let's get back to the change of base idea. Okay, look what I ended up with when I actually finally did my division, log of 12. Well, 12 was a piece that I was originally taking the logarithm of. Denominator, log of 4. 4 was the base that I started with. And so again, I get back to that base. I talk about the basement. Okay, the basement of your house is on the bottom. Okay, so maybe if you remember that, hey, if I'm using the change of base, I got to take the log of both values. Well, the base goes in the basement, goes on the bottom. Okay, if you don't remember to change of base, okay, you'll be okay, because I can still do that work. Okay, but it is one of those little shortcuts, helpful to remember, makes a few things a little easier for you. All right, so here's where we're going to start getting a little quicker in some of our examples. So exponents in the variable, that tells me I need to use logarithms. Power property allows me then to bring that exponent out in front. Okay. Now in this case I have 6 times x times log of 5. So again, to undo it's very similar, it's just there's more stuff than the previous example. I need to divide both sides by 6. Okay. And then I need to divide both sides by that log 5. Okay. So x equals log 13 divided by 6 log 5. Okay. Now, one of the things also that happens with our calculator, because of those parentheses, we can have some problems typing this one in. If I go log of 13, enter, divided by 6 log 5, enter, it tells me 0.1298. Now, we should always be checking these things. I always tell students that when you are doing equations, you should always be able to find out, am I right or wrong, just by plugging it back in. So my initial problem was 5 raised to the 6 times x power. So I got to put that in parentheses. 6 times x is 0.1298. Okay. And I didn't get 13. Okay. And part of the problem comes from right here when I divided. The calculator does the order of operations. So it took this answer and divided it by 6, gave me that answer, and then multiplied it by log of 5. What we really need to do if we're going to use the calculator and type in what I see is go log of 13, enter, divide by, then parentheses 6, log 5, 0.2656. Okay. So now when I go 5, raise it to the 6 times the 0.2656, I get something really close to 13, and the reason it's not exactly 13 is because I did some rounding off. Okay. So one of the things I like to do then is, like I said, I like to get my expression down to logarithm divided by a logarithm before I type it into my calculator. So in the numerator, I'm good. It's 13. Goes back to our properties. Okay. And what I'm going to do now is I want to take the 6 and put it back into the logarithm. So I'm using that power property again. And I'm going to take that back in, excuse me. And when it goes back in, it goes in as an exponent. Now, remember, 1298 didn't work. But now if I go log 13, enter, divide by log of 5 to the 6th, I get the 0.2656. And I'm going to show you a couple of other examples where we're going to do that same thing, where we're going to condense it back into a single logarithm, okay, which is kind of what we did a lot of in the previous section. Okay. All right. So again, variable in the exponent, logarithm both sides. Okay. What I'm going to do then is bring the x plus 3 out in front. Now, that's your whole exponent. It has to stay together. Now, there's two ways you can go about solving this one. Okay. Method 1. Okay. What I could do is I recognize that I have x plus 3, so I have something times log of 6.5. So what I could do is I could divide that 6.5 log of it away from both sides first. Okay, which would leave me then with my x plus 3 log of 200 log of 6.5. And then it's pretty simple because to get rid of my 3, all I'm going to do is go minus 3 on both sides. And I'm all set to go to the calculator. Log 200 okay, divided by log 6.5. And I'm going to hit enter again because that's going to give me the value of that fraction part. And then I'm going to go minus 3. So negative 1694. Okay. So again, if I want to check 6.5, raise it to the x, negative 0.1694 plus 3, okay, I get about 200. There's my solution. That's not a bad method to use, okay? But with the other method, what I'm going to do is, if I come back down here and start over, x plus 3 log 6.5 equals log of 200. When I see multiplication and I see parentheses, a lot of times I think distribution. Okay, and that's a second way I can attack this problem, and it's going to come into play when we get into the next example here that we're going to probably want to look at doing that distribution. So how it works is, remember, this is a number. I'm going to distribute that number through the parentheses. Now I want to put log, or x times log of 6.5. I don't want to put log 6.5 times x, okay, because I'll get mixed up thinking the x is part of the logarithm, which it isn't. I'm going to take this number times the 3. Now, one of the pieces I do, just like a regular equation, is try and get my x piece by itself. And so what I'm going to do is throw that over to the other side, which means I'm going to subtract it. Okay. And then to get my x, and here's where I'm saying you're going to probably have to pause to write some of this stuff down, I'm going to divide both sides by log of 6.5. Now, here's where the condensing comes into play, and it's important. So what I have is, on the bottom, I'm good. On the top, what I'm going to do is I'm going to take that 3 into my exponent. And because of the subtraction, it becomes division for our condensing. So I get better with my properties also by doing all this. Okay. And so now I'm going to type it into my calculator. All right, so there's my work. Got the same answer. And what I'm going to have to do is do another video to do the next example.